Say wolf, and most people imagine a legend before they imagine an animal. In stories, wolves are either terrifying villains lurking at the edge of civilization, or noble icons of freedom and wilderness. The real wolf is neither fantasy. It is a biological species, Canis lupus, shaped by evolution, landscape, and constant trade-offs between risk and reward. Understanding wolves starts by removing the mythology and looking at function. Wolves survive by making energy-efficient decisions: where to move, what to hunt, when to avoid conflict, and how to raise offspring in unpredictable environments. They are not chaotic predators attacking everything they see. They are strategic carnivores with social systems that reduce individual risk and increase group success. That distinction matters, because public debates about wolves are often emotional and symbolic, while effective management depends on ecological reality. If we want to discuss conservation, livestock conflict, or human safety honestly, we have to begin with what wolves are in practice: large social canids adapted for endurance, cooperation, and territorial life across Eurasia and North America. Biologically, the wolf is the largest wild living member of the dog family, Canidae. It belongs to a species complex where more than 30 subspecies of Canis lupus have been recognized in broader taxonomy, including domestic forms like dogs and dingoes. But when people say gray or gray wolf, they usually mean naturally occurring wild populations. Physically, wolves are built for stamina and control rather than short bursts of speed alone. Compared with some close relatives, they have less pointed ears and muzzle, a relatively shorter torso, and a longer tail that supports balance and communication. Their coat coloration is highly variable: gray, black, brown, white, and mixed patterns are all normal, with Arctic forms often appearing nearly all white. This variation is not cosmetic trivia. Fur pattern and color influence camouflage, heat management, and visual signaling in different habitats. The key point is that wolves are both diverse and coherent. They can look different across regions but still share a common ecological design. That design supports long-distance movement, coordinated hunting, and survival through severe seasonal change. Wolves are closely related to other canids such as coyotes and golden jackals, and they are close enough genetically to produce fertile hybrids. That fact sometimes causes confusion, as if wolves are just oversized versions of their relatives. They are not. Ecologically, wolves occupy a distinct role because their behavior is specialized for cooperative hunting of larger prey. Hybridization tells us about genetic compatibility. It does not erase behavioral and ecological differences. Wolves rely on advanced social signaling, posture, gaze, tail position, movement direction, and vocal cues to coordinate under pressure. During a hunt, this communication allows rapid role changes. Some individuals test prey movement, others flank, others conserve energy for decisive phases. Large prey can injure or kill predators, so mistakes are costly. Wolves reduce that risk through coordination that smaller or more solitary canids use less extensively. In simple terms, wolves are not just stronger, they are organized. Their success comes from how bodies and behavior fit together. That makes them one of the clearest examples of social strategy driving predator performance in the wild. A wolf pack is usually not a random gang. It is most often a family unit, a breeding pair and their offspring from 1 or more years. This family structure changes everything about pack behavior. Cooperation in hunting, pup care, and defense is not temporary convenience, it is long-term kin investment. Older siblings may help guard or provision younger pups, while adults coordinate movement and territory defense to secure food. As young wolves mature sexually, many disperse to seek mates and establish new territories. Dispersal can be triggered by food, competition, social tension, or simple reproductive opportunity. Importantly, leaving is not failure. It is a normal mechanism that spreads genes and reduces inbreeding. Pack size can vary with prey abundance, mortality, and habitat pressure, and bigger packs are not automatically more efficient in every context. Larger groups gain advantages in defense and tackling dangerous prey, but they also face coordination costs and food sharing pressure. So wolf social life is a dynamic balancing act, family loyalty, competition, reproduction, and energy economics all operating at once. Territory is the organizing framework of wolf survival. A territory is not just space on a map, it is an energy system containing prey routes, denning options, travel corridors, and seasonal refuge. Wolves defend territory through scent marking, movement patrols, and vocal communication, especially howling. Howling is often romanticized, but in ecological terms it is efficient long-distance information sharing. It can assemble pack members, advertise occupancy, and reduce accidental overlap with neighbors. Even with signaling, territorial conflict remains one of the major causes of wolf mortality. Why? Because overlapping claims can mean direct competition for the same limited prey base. When habitat is fragmented or prey declines, the pressure intensifies. Territorial tension also shapes dispersing wolves, which must cross occupied landscapes while searching for openings. This creates a high-risk life stage where mortality can be significant. Population trends therefore depend on more than births and food. They are also governed by social geography, who controls which space, how stable boundaries remain, and how often conflict escalates into injury or death. Wolves are carnivores and apex predators, but their feeding strategy is more flexible than many people assume. Large wild-hoofed mammals often anchor their diet, yet wolves also consume smaller animals, carrion, and in some areas human-associated waste. This flexibility is one reason they can persist in varied ecosystems, but it also fuels conflict when livestock becomes accessible. From a wolf's perspective, an unprotected domestic animal can be a high-reward target compared with chasing healthy wild prey. From a rancher's perspective, that same event is financial and emotional damage. Both perspectives are real, and effective policy must account for both. Hunting dynamics also challenge stereotypes. In some situations, single wolves or pairs can show higher success rates than larger packs, likely because fewer hunters reduce coordination friction and noise. Larger packs, however, can manage larger or more defensive prey and better absorb injury risk through shared effort. So there is no single wolf hunting template. Strategy shifts with terrain, season, prey behavior, and group composition. Wolves succeed because they adapt tactics rather than repeating one rigid pattern. Disease is a major but often under-discussed factor in wolf ecology. Pathogens and parasites can influence survival, reproduction, and behavior, and rabies is historically the most consequential in public perception. Rabies can radically alter fear response and aggression, which is critical context when evaluating reports of wolf attacks on humans. Many documented attacks have been associated with rabid individuals rather than healthy wolves showing normal behavior. This does not mean all risk is imaginary. It means risk assessment must distinguish between baseline ecology and pathological exceptions. Healthy wolves generally avoid people, partly because they are low in number relative to human populations, often occupy less developed landscapes, and carry learned caution from centuries of persecution. Public safety improves when management systems monitor disease, investigate abnormal behavior rapidly, and communicate clearly with local communities. Fear-based generalization can lead to poor policy, but denial of disease risk is equally harmful. Good management is precise, track health signals, respond to anomalies, and avoid treating every sighting as equivalent. That precision supports both conservation and human safety instead of forcing a false choice between them. As of 2026, global wild gray wolf numbers are estimated at roughly 200,000 to 250,000 individuals, and the IUCN classifies the species as least concern. That sounds reassuring, but it is easy to misread. Least concern at global scale does not guarantee stability in every region. Local populations can still face fragmentation, legal volatility, prey fluctuations, and high conflict pressure. Conservation status is a broad lens. It can hide local instability if used without context. Some regions have seen recovery driven by legal protection, reintroduction, and changing public attitudes. Others remain contentious, with ongoing illegal killing, policy reversals, or habitat constraints that limit long-term viability. Wolves also move across political borders that do not align with ecological boundaries, which makes governance difficult. Effective conservation needs multi-scale coordination, global tracking for overall trend, regional monitoring for practical risk, and local implementation that communities trust. The key lesson is that numbers alone are not the full story. Population count, spatial connectivity, and social tolerance must be considered together if management is meant to work over decades rather than election cycles. Human-wolf relationships have always been contradictory. In many pastoral systems, wolves were targeted aggressively because they threatened livestock and therefore household survival. In other cultural contexts, wolves were respected for endurance, intelligence, and social discipline. Those parallel narratives still shape modern policy fights. One side emphasizes ecological restoration and predator value. Another emphasizes economic loss, safety concerns, and rural burden. Productive coexistence requires moving beyond slogans into practical systems. That includes preventive husbandry, deterrence, fast investigation of depredation claims, transparent compensation, and clear thresholds for intervention when chronic losses occur. None of these tools is perfect, and none works well in isolation. What matters is consistency and trust. Rural communities need evidence that losses will be acknowledged and managed. Conservation stakeholders need evidence that control measures are targeted and data-based rather than symbolic retaliation. Wolves expose whether institutions can handle complex trade-offs honestly. The animal itself is not the only challenge, governance quality is. Where institutions are credible, coexistence is difficult but possible. Where trust collapses, conflict escalates even when ecological options exist. What, then, is the real significance of wolves today? First, they demonstrate how social intelligence can be an adaptive force as powerful as physical strength. Their success is rooted in communication, role flexibility, and family structure. Second, they show that apex predators are ecosystem processes, not isolated icons. Wolves influence prey distribution, carcass availability, and competitive dynamics, but those effects vary by context and should be evaluated with caution rather than mythology. Third, they highlight that conservation is not a one-time achievement. Even with a favorable global status, local outcomes depend on habitat connectivity, policy stability, and social legitimacy. Finally, wolves force us to confront our own narratives about nature, fear, admiration, control, and responsibility. If we reduce wolves to symbols, we make poor decisions. If we study them as living systems under real pressure, we gain the tools to manage conflict while preserving ecological function. The wolf story is not about perfection or menace. It is about adaptation under constraint, and about whether human societies can respond to complexity with discipline instead of reaction. If you found this helpful, please like this video and subscribe for more explainers.